Greetings to all the viewers. Thank you very much for your attention over here. And the content we are going to discuss in this session will be on Eastern synthesis. This is a content retrieved from organic named reactions. So, organic named reactions are very pivotal in the synthetic perspective. So many synthetic organic chemistry reactions are proceeded in terms of academia and research as well. So this kind of literature, whatever we are gathering, is very much important over there. And this is the concept which is collected from the textbook of organic named reactions, which is written by Dr. Kavita Kothireddy Kota. On ester synthesis, this is the one named reaction. In continuation to earlier session, we are going to start this one, and all the series of sessions available at the channel called World of Competitive Chemistry, right? So if you want to get the conceptual description regarding the chemistry, or else bit point of view in the examination concern, all are available at the World of Competitive Chemistry. Each and every topic uploaded over there, you can go through that. Those who are seriously preparing for the examination, aspirant for the chemistry related content for academia and research, this is very beneficial platform. The Arndt-Eistert reaction is the transformation of carboxylic acid into their homologs. So homolog is nothing but extension of the carbon chain is possible by one methylene group is said to be homolog. So that here Arndt-Eistert reaction mean for carboxylic acid to be enlarged with a one methylene functionality, that is said to be homologous, right? Named after German chemist Fritz on and Bent Eastert to credit for their establishment of the reaction. This organic reaction involves chemical reaction between acid chlorides and diazomethane. These are said to be treated. Very important to notice what the reactants are to be added and what reagents we are adding, so that final product will be achieved in a homologous manner, right? So here the reactants will be acid chloride is one of the component, diazomethane taken as the another component to be combined by the reaction on ester synthesis yields a higher carboxylic acid. Here, in comparison, one of the methylene got extended, right? That's the reason why you can designate they are said to be higher carboxylic acid through the ketene intermediate. The mechanism is accorded via ketene intermediate formation, mostly applied for the synthesis of beta amino acids. Beta amino acids are the final products, and alpha amino acids are taken as a starting materials. This is the kind of application you can notice. Arndt-Eistert synthesis started with carboxylic acids only and ends with again carboxylic acid. Only the distinctive factor is the extension with the methylene group. CH2 will be uplifted. CH2 group will be introduced within, so that higher carboxylic acids are the expected products. So schematic representation for the chemical equation is provided. You can start with the acid chloride. I'm taking C double bond OCl. That is treated with diazomethane. Diazomethane is another reacting species. It able to generate the carbene intermediate by homolytic fission of the bond, discarding nitrogen. And here the formation of carbene intermediate will be originated. Whatever carbene generated, that here RC double bond or Cl able to react with RC double bond or double bond into H. This is the kind of molecule is said to be alpha beta unsaturated carbonyl compound. Silver oxide taken as a mild oxidizing agent in order to discard this nitrogen. Nitrogen is the kind of is the leaving group, so that nitrogen will be departed over there, and there is a provision for this ketene intermediate. In order to achieve this ketene, there might be alkyl group shifting, alkyl transfer of alkyl group taking place, so that ketene intermediate can be generated, which is indicated in the square bracket, being it is non-isolated. Immediately go for the equation, right? Water molecule will be added over there. Whenever water is added upon the intermediate ketene, that is supposed to be converted into a higher carboxylic acid. What process taking place whenever water is added? The carbon whichever present in between is a simply linear, being it is surrounded by one side double bond in either side double bond, so that it is completely linear one. And whenever the kind of bonded electrons taking place, bonded electrons are moving away from that carbon atom, so that hydroxyl will be combined at this carbon atom, and this, subsequently the carbon whichever taking the electrons will be added with the proton from this one. Simply you can go for the addition reaction in between this double bond. Whenever addition reaction is carried, RC double bond is converted into CH2 moiety, and wherever the carbon is there, that is added with the OH, so that you can notice the hydroxyl functionality. Existing ketone remains as such. Simply it is turned into a higher carboxylic acid. This is the way a ketone intermediate now transformed into a higher carboxylic acid. The starting material might be acid chloride. This is the way a kind of series of reactions taking for Arndt-Eistert synthesis process, right? Carboxylic acid, this is in either alternative pathway. You may start with carboxylic acid, right? Carboxylic acid and finally carboxylic acid. In order to achieve that reaction, one more step to be added for this. In order to get that one, let me start with the carboxylic acid. Halogenation of this one acid derivative will be generated. So that let me introduce the reagent called thionyl chloride, which is the efficient chlorinating agent. Whenever chlorinating agent is added upon the carboxylic acid, it converted into a acid chloride. Acid chloride will be treated with diazomethane of 2 molar ratio, so that here there is a kind of a compound called alpha diazoketone. Alpha diazoketone formation taking place. Silver oxide is the reagent added in order to discard the nitrogen, and there is a formation of ketene intermediate at some subsequent hydrolysis, giving the final product homologue of carboxylic acid. A chemical transformation is provided starting with carboxylic acid and ending with carboxylic acid as well. So let me introduce the what you can say is ethyl chloride diazomethane to be added, and here is the kind of diazoketone intermediate, silver oxide giving rise to ketene, and final product will be a kind of homologue, that is propionic acid. One of the carbon got added. So on ester synthesis chemical reaction elongate the carboxylic acid chain by means of one CH2. Hence, you can designate as a homologue. Homologue is meant for the extension of carbon chain by one CH2 unit, right? If you compare ethane and methane, both are exactly similar. Both are hydrocarbons, only distinguished by CH2 unit only. That only the difference. Both are said to be homologous with each other. This method is particularly useful for converting carboxylic acid into homologous carboxylic acid, and involves the transformation of carboxylic acid into their corresponding alpha diazoketones, which then undergo Wolff rearrangement. This reaction from diazoketone into ketene intermediate is regarded as a Wolff rearrangement, and that gives rise to the extended carboxylic acid as the final product by hydrolysis process, right? If you want to observe the entire mechanism for the reaction, first of all, we need to go for the halogenation of carboxylic acid, so that acid derivative acid chloride will be originated. In order to get rid of this reaction, carboxylic acid is supposed to be reacted with thionyl chloride, so that acid turned into acid chloride, and the byproducts will be sulfur dioxide and the hydrochloric acid. This is the step number one, acid to acid chloride formation you can accomplish. After getting that one, you may treat with this diazomethane. Whenever diazomethane is supposed to be added, there is a bond formation between these two. This chloro is discarded. Here the hydrogen discarded. Simply you can notice hydrochloric acid as the byproduct. Whenever hydrochloric acid is surpassed, then you can notice RCOCHN2 as the intermediate compound, that is diazoketone formation is possible. Now the named reaction is operated under mild acid catalytic conditions, and being it is a light irradiated reaction, so that here photochemical reaction also plays over there. So here the entire mechanism proceeded with the free radical. You can notice the Wolff rearrangement wherever diazoketone is there, either under thermal or photochemical conditions. There is a formation of ketene intermediate by eliminating nitrogen as the byproduct. Nitrogen gas evolved during this reaction. After getting the ketene intermediate, simply you can go for the hydrolysis addition of this double bond with the water molecule. You can notice the higher carboxylic acid as the final product. Overall reaction, RCOO is turned into RCH2COH. This is the important one. This transformation is the important one by Arndt-Eistert homologation process. In order to understand the entire reaction, let me give the schematic representation for the mechanism. Right? Thionyl chloride able to convert carboxylic acid into acid chloride. Later on, diazomethane to be added. Diazomethane chemical structure representation is provided for the better understanding how the addition taking place. Right? Here is the nitrogen with the triple bond with the quaternary being four bonds around the nitrogen will make it electron deficient positive, and the carbon experiencing a negatively charged electron density. This is the reason why here is the nucleophile. Nucleophile are this carbon atom. This nucleophile is susceptible to go for the reaction at the carbonylic carbon atom and simply leaving this chloro. So that here the carbon to carbon new linkage is originated. Whenever carbon-carbon new bond established, here is the kind of diazoketone intermediate formation. The diazoketone intermediate is supposed to be treated with silver oxide by the elimination of nitrogen. Being nitrogen is very heavy in nature, it is easily eliminated from the reaction mixture. Whenever nitrogen is removed from this one, here the what you can notice here the formation of carbene intermediate. Here the carbene intermediate you can observe, but here also carbene intermediate formation is possible. So here the thing you need to remember will be in the examination point of view, on Eastern homologation process is accomplished via carbene intermediate and ketene intermediates. So carbene formation followed by ketene intermediate. Both the intermediates involved in the same reaction in this kind of named reaction. Whatever carbene generated is a very reactive in nature, right? So that is the reason why within the molecule, intermolecular alkyl rearrangement taking place. Alkyl group transfer, you can notice this is the entire process named after Wolff, so that Wolff rearrangement it might be. Whenever Wolff rearrangement taking place, lone pair on the carbon atom is participating in the pi bond formation in between. Wherever vacant side is there on the carbon atom, carbene works like a ambident. It is like a electrophile and nucleophile as well, where vacant orbital is located upon and a lone pair of electrons as well. That's the reason why it accepts the electrons from this alkyl functionality, and this lone pair is able to generate the new pi bond in between the carbon and carbon atom. This is the way carbene intermediate will be originated. Sorry, ketene intermediate will be originated. Later on, you are supposed to treat with the water able to bind up at the carbon. This olefinic double bond will be broken and the simply addition reaction taking place, giving rise to higher carboxylic acid. This is the way a clear mechanistic representation is provided for an ester homologation process. Later on, a key step in this reaction will be Wolff rearrangement. Conversion of carbene intermediate to ketene intermediate is the deciding factor in this entire process. This is a driving force over there, right? Formation of acetyl chloride is step number 1, and formation of diazoketone is the step number 2. Formation of diazoketone to ketene intermediate is the Wolff rearrangement. This is a key step within the entire process, and subsequent hydrolysis of ketene giving rise to a carboxylic acid. Mechanism of the action, as we already know, thionyl chloride is the chlorinating agent and a methylene group able to bind up at the carbonylic carbon atom. Subsequent chloro discharge, and you can notice the new bond over there, silver oxide able to oxidize this one, and nitrogen decomposition by Wolff rearrangement and ketene intermediate hydrolysis giving homolog process. Right. Let me extend the reactivity for various kind of reactions by discussing about their examples in the concept of Arndt-Eistert reaction. So let me take this paranitrocarboxylic acid, paranitrobenzoic acid in specific, that to be treated with thionyl chloride, acid to be turned into benzoyl chloride. Benzoyl chloride is supposed to be treated with dinitromethane in the presence of mild base like triethylamine. Ether is the solvent in order to accomplish the reaction at this solvent medium. So that this acid chloride is turned into that diazoketone. Diazoketone is supposed to be treated with the mild oxidizing agent silver oxide. Hence, you can absorb the ketene and subsequent hydrolysis CH2COOH. That is homolog. If you observe, here is the directly linked carboxylic acid. Here is the aliphatic chain linked to the carboxylic acid. Hence, we can denote it as the homolog. Let me introduce another reaction of long chain. Here you can notice the amide linkage and here the free carboxylic acid. This free carboxylic acid is our point of discussion. Remaining all will be a kind of whatever functional groups located, we are not going to disturb them. Rather, the focus point will be this carboxylic acid to be treated with triethylamine and followed by ethyl chloroacetate and followed by diazomethane. Whenever these many reactants are working upon this one, here what ethyl chloroacetate is supposed to convert this carboxylic acid into acid chloride. Chloride is more reactive in comparison to this carboxylic acid. That is the reason why acid to be turned into its acid chloride derivative. Later on here diazomethane supposed to be added over there. Whenever diazomethane is adding, so there is a formation of diazoketone intermediate. Diazoketone intermediate further go for Wolff rearrangement simply. So here the entire process is a very familiar with the Wolff rearrangement and giving rise to one carbon increasing carboxylic acid. Again, it is the homolog. Whatever else a functional group remains in the molecule will not be affected. Rather, we are simply focusing upon this terminal carboxylic acid, where you can notice the carboxylic acid is extended with one methylene group as a homolog. This is the way Arndt-Eistert reaction is accomplished. So that many more successful applications in the laboratory you can notice for this reaction. By taking this ketene, not only the carboxylic acid, but you can achieve the various other derivatives of the carboxylic acids as well, right? So that is possible by treating the ketene, whichever generated as an intermediary compound, that to be immediately treated with water. That is expected higher carboxylic acid as the product. Otherwise, you may go for the alcohol reaction, hydroxyl compound to be working upon this ketene so that you can achieve CH2C double bond OR. Rather than carboxylic acid, it will be turned into its derivative called ester. Whenever ketene is supposed to be treated with primary amine, there is a formation of corresponding higher amide formation is possible. All these are said to be a kind of exploration, research exploration. Can we extend the same research to any other kind of derivatives other than carboxylic acid? In this manner also, scientists will think, scientists will explore the reaction in all possible dimensions so that multiple kind of research exploration is possible and research achievements will be possible. This is the way ketene is able to generate carboxylic acid, ester, and amine in multiple reaction combinations, right? So by this examples part was completed, let me introduce applications of Arndt-Eistert chemical transformations. So applications we are going to discuss in general. Without applications, any kind of reaction will go wasted. That's the reason why this is the important sector of this named reaction. Arndt-Eistert reaction is applicable for the synthesis of higher member of aliphatic carboxylic acid, as we already aware about that, right? That is the reason why if you are taking stearic acid of very long chain with the terminal carboxylic acid, that to be supposed to be go for Arndt-Eistert homologation reaction, and one of the methylene group got introduced so that this compound will be turned into a next level, and again the same reaction is repeated one more time so that one more carbon methylene group is introduced so that the tail of the snake is elongated, just like the snake game in the mobile. In the same manner, here is the elongation of the chain length is possible. This is called eicosanoic acid. And here again the reaction is repeated one more time so that here henicosanoic Henicosanoic acid. So this is the way a kind of chain elongation simply with the one methyl functionality is possible. Starting with the stearic acid, let me count the number of carbon atoms: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 carbon chain by an Eastert homologation. You can achieve one methylene so that 19 it will be, later on 20 it will be. And the final product, hino Hinoicosanoic acid is a 21 carbon chain. It will be. This is the way a kind of applications you can locate. You can extend the chain length by simply by this named reaction. Let me introduce the starting material, trifluoroacetic acid. Trifluoroacetic acid is strongest in comparison to acetic acid. Most of the people are aware about this. And moreover, it is the kind of very important examination bit and critical for the logical acidic strength, right? So that is the reason why it is a strong acid in general. Trifluoroacetic acid you can designate. On Eastern homologation accomplished in multiple steps, right? So multiple steps accomplished. Finally, the compound is turned into CF3CH2NCOH. That means what? Multiple times you are applying the same named reaction. That is the reason why in between this CF3 carbon and COH carbon, multiple CH2 groups got introduced. That depends upon the number of times you are repeating the same homologation process, and hence you can achieve finally CH2 taken n times. The n depends upon your requirement of applicability. That is the reason why homologous series of trifluorocarboxylic acid is the final product as a polymeric one. This is the way you can apply. Wherever you want, there you can achieve the chemical transformation. This is the reason why the research is very interesting and important as well. And application perspective also, there is a kind of multiple domains to achieve the successful products. Homologation. On-ester synthesis is valuable tool for homologation of the carboxylic acids, providing the method to extend carbon chain by one carbon unit. Methylene unit will be extended. That's the reason why, in comparison to the starting material and final product, exactly same resemblance. Only the thing is methylene group introduction. Synthesis of amino acids also accomplished by means of this one. How can you achieve that one? Simply, carboxylic acid is the starting material. Obviously, instead of carboxylic acid, you may take amino acid, so that the same process applied upon that one, and the finally you can achieve again amino acid of a somewhat lengthened. That means elongated one. This is the way the synthesis of ester synthesis can be extended for amino acid synthesis. Amino acids are more crucial for protein synthesis and subsequently DNA manufacturing, RNA manufacturing, so that it is becoming more potential. This compound Arndt-Eistert reaction is becoming more potential in the perspective of applicability, right? So woody biomass can be taken simply. This is the natural material everybody aware about. So wood can be collected initially from the plant, and by means of this reaction, feeding to protein enriched food is possible. Protein enriched food manufacturing is possible. Being amino acids are starting material for the protein synthesis, everybody know about that one. And even from this protein, even from this fish also, you can collect the protein, and you can synthesize the same protein from this same Arndt-Eistert synthesis. This is a natural phenomenon you are aware about. Even by combining the compounds like carboxylic acid, this carboxylic acid, which is collected from the biomass, and ammonia to be added over there in order to achieve that alpha amino acid, heterogeneous catalyst applied for this transformation, and you can achieve alanine, tyrosine, others, aspartate. These many kind of amino acids, if generated, they got condensed. Condensation taking place by removing the byproduct water, so that protein will be achieved. Either of the way, you can proceed for the manufacturing of protein. Arndt-Eistert synthesis is also taking part of this protein synthesis. Protein synthesis is the important biological transformation, right? This is the reason why it's important, got exponentially elevated. So this is the way applications are discussed in synthetic organic chemistry. Obviously, multiple reactions, carboxylic acid being it is highly reactive in nature. Moreover, multiple derivatives you can synthesize by starting with carboxylic acid, so that it's very convenient to take this carboxylic acid starting material as a research objective in the field of research and also academia as well. That's the reason why on-ester synthesis related with the carboxylic acid only. Obviously, it will be more outstanding a phenomenon in the synthetic organic chemistry. On-ester synthesis widely used in organic synthesis because efficiency and broad applicability. Methods for extending carbon chains of carboxylic acid. You may synthesize amino acids. It is possible to generate the peptides and fatty acids. Natural product manufacturing is also accomplished by using the same named reaction. Carboxylic acid homologous can be generated. And how the mechanism proceeded, you can isolate by means of deuterium labeling, isotopic labeling process. This is the way synthetic organic chemistry also taking part of this on-ester synthesis. This is the most potential in this synthetic organic chemistry. By this, successfully we accomplished the entire session on ester synthesis, its origin, what reaction taking place, what mechanism is there beyond the reaction, and how can we extend the reaction for multiple starting materials, and what examples we noticed as of now, and what applicability is there for the reaction entirely discussed in detailed manner. And the next session, it is the topic called Huston cycloadhesion, azide alkyne 1,3-dipolar cycloadhesion is the topic for the next session. Hopefully, this session is really informative and applicable and most important for the research exploration further. Whatever chemistry kind of topics you need to observe, all are available at the channel called World of Competitive Chemistry. Thank you very much for your patient listening.